We're going to have a good presentation from Evergreen looking at the container temperature study that they've been working on. This was something that we discussed in Singapore, and I know there was a further discussion in Bangkok. So we're interested to hear some further updates on that. So before we introduce the speakers, I'm just going to hand over to Captain Y.S. Wang, who's going to give a short introduction. Captain Wang, over to you.
Well, thank you, Patrick. Call me YS, by the way, please. Thank you, everyone, for attending today's webinar. Today, my team will be reporting to you the update, like Patrick said, since last meeting in Singapore. We have more data collected, and we try to analyze it all, but we found it difficult. However, still we have made some progress. But let me introduce my team first. Teams, can you please switch on your camera, or already switch on?
I think we already switch on.
Okay. I have Roderick, Mr. Chen. Roderick, can you say a few words?
Hello, everyone. I'm Roderick. So I'm mainly in charge for Europe section for storage planning. Hello, everyone.
All right. And Justin, good afternoon.
Hello, everyone. I'm Justin. I'm in charge of the Near East Middle East section, and also in charge of storage software. Hello.
Thank you, Justin. And Yvonne, the EDI expert.
Hello, everyone. I'm Yvonne. I'm in charge of our company's operation system. Nice to see you.
Yeah, thank you all. Before we start the PowerPoint, the briefing, I have a few words to say. Container temperature study is nothing new. It's not a new thing. If you search on the internet, you may find several articles about container temperature or container climate. But you may also find that most of them, if not all of them, are cargo integrity oriented. It is all about the cargo, how to make sure the wine exported from Australia and reaches destinations still in good quality. It's all about the cargo. What we are doing today is about the people, about the fire safety. So we have a different angle to look into this subject, container temperature. Also, I think after so many years now, we have a better tool to collect those temperature data. So I think it is a good timing to revisit this container temperature study. Can we start the briefing, the material? PowerPoint, please, Roger. Thank you. So today's topic is container temperature study and critical cargo information exchange, which we feel is two crucial elements to build a safer container transportation environment for all women and people working in this industry. Next page, please. In today's briefing, the first part is the fire risk and the information exchange. We will explain more in the following briefing. And the second part will be two cornerstones we feel is crucial. One is the understanding of the container temperature, and second thing is the attribute code that SMDG developed, still under developing, but I think it is also ready for all stakeholders to adopt. And the third part, the main part, is the update of the temperature study. And the next will be the attribute code SMDG. And number 5, ongoing task. And lastly, a safer environment. That's what we are looking for. Next page, please. 35 degrees centigrade. That's what we learned from some battery manufacturer. Not all of them. You may not find a specific storage temperature guideline from all the battery maker, but I think 35 degrees is, in general, from the battery maker's point of view, a safe limit of storage, the lithium battery, non-dangerous goods, for a certain period. Or otherwise, if you exceed this threshold, you have a risk of a thermal runaway, which means a container fire will likely follow. Next page, please. We also know 35 degrees is the melting point of the cocoa butter, of course, non-DG. Next page, please. For the terminal side, that's what we learned from China terminals operators. They have a 35 degrees mechanism to activate the water system to cooling those temperature sensitive dangerous cargo in the terminal. Last August 2nd, the highest temperature is 40. It's pretty hot, pretty warm in mainland China at that time. So, and you can see from the picture, they have a fixed system to cool those temperature sensitive cargo. So another 35 degrees for your reference. Next page, please. And as we all know, 55 degrees centigrade is the well-defined sources of heat in the IMDG code. So this is the two very specific temperature threshold we are looking at. Next page, please. So the fire risk and the information exchange. I think a better information exchange flow by adopting the SMDG developed attribute code among all stakeholders will be very helpful for the fire risk management. Next page, please. And I will invite Roger to explain you more about why we feel it is crucial to have a better information exchange. Roger?
Thanks, Wise. So we can see two pictures here. So in the left-hand side, you can see one of our vessel, which 24K vessel, which is serving Asia to Europe trade at the moment. So this is one of her voyage. So we took all the dangerous goods on board and we mark clearly from our vessel structure directly in our software. So you can see all those red containers are dangerous goods. In the right-hand side, you can see there have some yellow containers, which are containers which are sorted from our booking system. They're actually non-dangerous goods, but critical cargo, such as non-DG lithium-ion battery, cocoa butter, or carbon black. And this is actually what we want to do. So in the future, if all the attribute code can be implemented, then we can sort it out all those critical cargo in our plan directly. Hand it back to you, Wise.
Thank you, Roger. In another word, visualization is crucial to a better container fire management from our point of view, not just on board the ship, also in the terminal or in the depot. You need to see it. You know where are those critical cargoes are. You can take better precaution measures. Next page, please. So that's the two cornerstones I mentioned earlier. One is the understanding of the temperature and the attribute code, the implementation of the attribute code. Thank you. Next page, please. Now, this is the main body of today's briefing, the temperature study. We're going to have you an update. Please feel free to raise your hand if you have any question. Just stop us. Thank you. Then I will give the floor to Justine. Justine, please.
Thank you, Captain. So it's my turn now. So after our colleague Wyatt delivered two cornerstones in our presentation, so now let's get into the most important part, the temperature study. So before we start, we want to firstly mention our principal rule, IMDG code. It will define 55 degrees in threshold temperature. Based on that, we observe direct sunlight versus heated ship structure. And we also learn what is the definition of protected from source of heat in IMDG code, chapter 7.1.2. But in our experience and study, we think critical cargo threshold temperature 35 degrees also deserves our attention. So we would like to research more information through our studies. What we aim to understand is first how heat sources, such like direct sunlight or nearby ships' heating structure, impact the temperature inside of a container. And second, how the container's internal climate change during its transportation and associated cargo fire risk. And last, how to manage container fire risk in better way. Now we are going to introduce our settings and findings. Firstly, we want to introduce these helpful tools and equipment we are using. Thermal imaging camera, we can just call it TIC, and weather data logger, and portable weather station. Here we can see an operating reefer scanning by TIC. We can easily find the heat spot, especially for heating pipe and engine unit. As you can see the photo in the middle part, this is highest temperature 92.3 degrees we got. And next, this is the temperature data logger we used. It can record most of climate parameter timely. We put these loggers in different positions and try to get objective data to have comparison with the environment. And last, portable weather station. What we used for this weather station we used, despite of the climate parameter, it can record for wind force and direction with GPS position, and which would be helpful to understand the ambient environment to have objective standards. So using these tools, we have conducted total 28 surveys till now. So as previous Wise just mentioned, this is ongoing task. We're still doing it in 2025, and we survey in various places. So you can see we collect this temperature data in land, at sea, on ship, and in container. Based on these different settings, we got many interesting findings. So we picked 4 from 28 surveys to elaborate more detail and hope to give a quick overview. So Roger, you may take the floor.
Thank you, Justin. So then it's my turn. So we pick up 4 surveys, which we have done for 28. So the first one is we made in our depot. So we took 3 different containers, 1 reefer, 1 evergreen container, and 1 maroon container, which charted. So we put in our depot for those 3 empties, and you can see the left-hand side, the picture. So we put 2 data loggers outside of the depot to get the ambient climate data. And we put also in all containers, we put 1 data logger inside and hang on in the middle. So then we can took comparison for all these 3 different containers. In this page, we sorted out all the data loggers data. So the black line stands for the air temperature, which sorted from data logger for the environment. So we can see the temperatures nearly always stands from 30 degrees to 35 degrees. Then we see the red line, which stands for the maroon container. You can see this line is a little bit higher than the green line, which is for evergreen containers. We thought it might because of the color coating, so which makes the maroon container, the temperatures a little bit higher than the green one. Then we can see the blue line. The blue line stands for the reefer containers. So actually we can see from the beginning to the end, the reefer container is quite stable. The temperature is quite stable inside. And is this really good for our critical cargo? It's a doubt actually. So we can see from the 1700 to 6 in the morning. After sunset, the reefer containers inside temperature still maintain a really high temperature compared with other 2. You can see the other 2 containers temperature drop very sharply, but reefer container not. So this is an interesting part we found in this study. Then we jump to the second one. So we elaborate more from the first study. So we block the whole container area in one of our great terminal in Kaohsiung. So we put 9 containers here. So you can see the picture showing here. So 1 is unprotected, 1 is topped, and 1 is protected. And also we again put the reefer and the maroon containers there. So here shows how we put the data logger inside of our container. From the left-hand side, you can see we put all the data loggers in the logging rings, so which we can get all the data to compare all the temperature distribution in the container. And the right-hand side, we also put each container one data loggers in the middle part of container, and we leave 65 centimeters space from ceiling. And we try to gather the middle temperature to make comparison for all the containers. So this is the actual true course for our containers which put in yard. So we can see if we stand in front of the container door, in your right-hand side is the sunrise, and in your left-hand side sunset. So this gives us clear picture that when the sunlight come from which direction. So here is the data we acquired at that time. We took TIC reading. So actually, the experiment took around a week, but we took the TIC reading on 27th of September. So you can see at that day, the sunrise is at 5:38. But when we took the reading, it's at 1500. So which means at that time, if we face to the container door, the sunlight is actually coming from my left-hand side. And please be careful, at that day, it's partly cloudy. It's actually not really sunny day. And also we got wind force there, 19.0 kilometers per hour. So now we look to our TIC reading data. So the first one we took is the container A. We can see here it's totally unprotected container. We can see the TIC reading from outside is 57.7 degrees Celsius, and in the inside is 61.7 degrees Celsius. So which means inside temperature is a little bit higher than outside, and which is totally already reached the 55 degrees Celsius threshold, which could make very dangerous. Then we took, in this page, we look reefer containers, which is also unprotected. So we got nearly same result as our first study. So the inside of the container is only 38.1 degrees Celsius, which means the reefer insulation is quite good. And we got same result. So in the reefer, it still got the threshold, 35 degrees Celsius. So if we really put critical cargo inside of non-operated reefer, is that really helpful? It's a question at the moment. Then we look at the container C, which is in the right wall shading. So as you remember, I just mentioned, at that timing, the sunlight is actually coming from our left-hand side. So you can see the outside reading is 54.1 degrees Celsius, and the inside is already 59.4 degrees Celsius. We can see the right hand, this picture, which we took from TIC inside of the container. You can see the protected area, actually the container temperature is quite low, but from the sunlight directly hit it, it's quite high temperature inside. Then we look at the container D, which is totally protected. So we can see actually the temperature is dropped very sharply. So outside is 49.1 degrees Celsius and inside is 47.6 degrees Celsius. And if we look at the TIC reading picture, you can see actually the highest temperature is coming from the top left side, the sidewall. So which is actually the container light, which is leakage from the protected area. Then we put all this data together. So it's nearly 9 days data from data logger. So we can see the black line is the same, stands for the air temperature. So we can see the 22nd and 23rd, why the temperature is always near the same. It's easily to get the answer. So at that 2 days, there has no sunshine, it's overcast weather. So we can see the temperature reading is nearly the same. Then we look other days data. So we can see for the reefer containers, orange line stands for reefer container. It's always got the same result. So the temperature is quite stable, but it's always over the threshold, 30 degrees to 35 degrees interval. But for the container D, we can see the brown color stands for the container D. We can see the temperature is really lower than other containers. So especially when the sun sets, the container temperatures drop very sharply and lower than 30 degrees. And the highest during the daylight time is only 40 degrees, the maximum. But for the other containers, when the sunlight comes from any direction, directly heated, then it's always going very high temperature, nearly 55 degrees Celsius or 50 degrees Celsius. We can find more other interesting insights from these pictures, but I leave it for all our participants to find out. So this is the third study we made for our 24K vessels. So we transfer to our vessel site at the sea. And this vessel is also served in Asia-Europe section road. And we put 2 data loggers on our vessel, and it's in our number 3 cargo hold. And one is actually in front of our fuel tank. And another one, we keep a 40-foot units interval and in front of the first one. So this is actual her route, started from August and arrived Europe on October. So we can see from all the summertime, it's going through all the Asia port, from higher latitude to lower latitude. And this is her back road, started from October 19th to December 7th, and her whole voyage. So we gather all the 106 days data from those data loggers. So we can easily found out that both for blue line and also orange line. So blue line is actually the data logger which near the fuel tank, and orange line is the data logger in front. We can see the blue line is actually the higher than the orange one. So which means heated structure is really affect to the temperature inside of the cargo hold really. And also we can see the air temperature and sea water temperature. We can see actually the air temperature is not more relevant to the cargo hold temperature. We will see the trend is more or less following the seawater temperature, which is more affected to cargo hold temperature. And in this chart, we can also found. So if you are serving in a high latitude area, so the temperature is very stable, especially when you are in Europe. But if we serve the vessel in the low latitude area, then the temperature is always near this threshold, and which could affect to our critical cargo if we put inside of cargo hold. So we made one study for our Europe trade vessel. Then we also trying to sort one data from our America trade vessel. So this is one of our reading from our 12K vessel from Far East to US East Coast. And the voyage started from summertime, September, and end of voyage at October. So we can see actually the voyage started from high latitude, so which means the temperatures dropped sharply a little bit compared with the temperature in low latitude. In this study, we can see, okay, started from 13 north latitude to the 30 around. So this is total 12 days, which means the cargo hold temperature is always reaching the threshold, 35 degrees Celsius. So we have to think about if we really put critical cargo in cargo hold, which might always keep the temperature in the threshold, and that might get dangerous if there has some really case happen. Therefore, from all these studies, we get few notes here, and I want to share to all our participants. The first one, other than container type, the external climate, the geographic location, and the seasons are crucial factor affecting the container's internal temperature. Also, the important part, the sunlight, is a key factor. Second, many aspects must be carefully reviewed before determining the storage of critical cargo on or under deck of a ship. However, the temperature data collected suggests that the cargo hold temperature may stay over 35 degrees Celsius for days, if not weeks, subject to the itinerary. This fact may deserve attention. So as we just showing, in the cargo hold is really better than on deck. We are doubt at the moment. Third, suppose the contents of those containers, which are temperature sensitive and critical to fire risk, are visually identifiable on the individual stakeholders' software. In that case, it will help the parties involved make safer storage arrangements and facilitate better container fire management. So as we showed in the beginning, which YS mentioned, those pictures. So for those critical cargo, if we can show really clearly on our software, then maybe we got more chance to have better storage and also have better monitoring for those containers. So this is few notes from here, and I want to hand the floor back to YS.
Thank you, Roderick. Very good. Can we go to next slide, please? All right, and have a quick recaps. Next page, please. So we feel visualization helps fire prevention. We need to see it where those non-IMO cargo is on board ship, in the terminal or in a depot. Next page, please. So again, that's two temperature threshold we are really focused on. One is the 35 degrees centigrade, and the second one is the 55 degrees centigrade. For information exchange, both at sea and inland, we need to promote the attribute code being used in the EDI message. And for the storage alone, for the storage of a ship alone, for on deck or in hold, we may have more consideration before making a decision for those critical cargo. Next page, please. In the following section, I will invite Yvonne to elaborate more about the information exchange. Yvonne, can you please?
Thanks, Wes. From previous slides, we can know temperature is a very important element for a critical cargo. And SMDG already set up the attribute code list under his website. So I think we can start to follow the attribute code to show it under EDI Exchange. Here I show you three common critical cargo attribute code for your reference. First one is LIB, stands for lithium battery, non-DG. Second is COB for cocoa butter and the cocoa beans. Third, LIO stands for lithium iron battery, non-DG. So we can use this attribute code under EDI Exchange to let all stakeholders know this is a critical cargo. We can also find on the latest version, version 00B for Copan, Codeco, and the query EDI message. SMDG already set up, we can show the attribute code information under FTX free text segment plus ACF to show the additional attribute information. So we can add this information under EDI Exchange to let all stakeholders to know this is a critical cargo as well. Then for the latest battery version, version 3, SMDG already set up, we use the ATT segment for missing attribute information. This is a little different with a previous query, Codeco, and Copan message. We can show the attribute code information under ATT segment to let all stakeholders know this is a critical cargo. Here I use part of container information flow to show you how we do the EDI exchange. When we got the information, the most important thing we have to get this information from shipper. When shipper take booking, they must provide the correct commodity. Then booking desk can base on the correct commodity to find the correct attribute code to well maintain it on the booking data. Then box operator and carrier, they can base on the attribute code to well mention this on EDI Copra exchange for cargo booking forecast. When box operator provide cargo booking forecast by EDI Copra, they can well mention this is attribute code under FTX plus ACF segment to advise vessel operator this is a critical cargo. And also when carrier provide compound data and the Copra data, container loading list to terminal, they can also well maintain this attribute code information under FTX plus ACF segment to advise terminal this container is a critical cargo. Then after container was actually loaded, terminal will send back EDI query, container loading confirmation, and the Codeco get moves back to carriers. And the terminal can also well mention this attribute code information under EDI query and Codeco FTX segment to show the attribute code information. And also after vessel departure, terminal will send departure battery message to carriers and also to ship. They can also well mention this critical cargo's attribute code information under ATD segment to let all stakeholders know this is a critical cargo. So we already have the attribute code set up by SMDG and also standard EDI format to show the attribute code information. So next step is to implement attribute code information under EDI exchange. This will give all stakeholders, including carriers, box operator and vessel operator, terminal, and settlers, a better chance to pay more attention and take better precaution for critical cargo. Because safety is always our first priority for maritime industry. So let's work together to move on to next step. Thanks. I hand over to Vice.
Me again? Okay, thank you. Very good, Yvonne. So the ongoing test remains is one, the temperature study, we're still doing it. We're still analyzing the collected data. It's quite time consuming. And then we are conducting more surveys even while this webinar is going. Then we are open to share what we have get those data to you. And we sincerely hope that you can give us some advice from your point of view. Maybe you know some better tools can be used for those surveys, or you may have a very different interpretation of those collected data. Please let us know. We are eager to learn from you how we can do this job better. And the second thing is the container message information exchange to adopt the SMDG attribute code list. But just to be clear, we are not quite there yet for system-wise. Still, we have some internal challenge. However, we do believe that's the direction we should move forward. Next page, please. This is the destination we want to arrive, a safer environment for all women and men working in this industry. It doesn't matter on board a ship, in a terminal, or in a depot, or even a trucker or the rail company. People should have the right to enjoy a cup of coffee rather than fighting a fire. So I do believe if the industry or stakeholder, we work together, we can build a safer environment. Next page, please. We conclude our briefing today. We are still doing it, the container temperature study, the surveys, and we are also working on the implementation of SMDG code, trying to identify those non-DG but critical cargo. And right-hand side on the screen, that's what we want to achieve. On board ship, or again, in the terminal or in the depot. Next page, please. Do we still have next page? Oh, we do have. Okay. This is just some supplements information for your reference. It's an actual case. It's nothing to do with the fire, but to do with the cocoa butter. You can see the itinerary last June, this cocoa butter container arriving at Pasikudan in Malaysia. Stay there for 7 days before loading on board the first leg, the first ships. And then this container stay being discharged at Kaohsiung, stay there for 4 days, waiting for transship. And when this container arriving at Kobe, Japan, this container stay at the terminal for another 10 days. So what this explains is this container itinerary from the terminal receiving at the port of loading the terminal until the consignee pick up the container from the port of discharge terminal. It took about 4 weeks, but there are 3 weeks, about 28, let's see, how many days? 7 days, 10 days, 17, yeah. It's exactly 3 weeks stay in a marine terminal. So we feel that for the terminal, it is also a critical element when we talk about the container temperature, the container fire. Next page, please. This graph shows the container's itinerary for your better understanding. Thank you very much. I think with that, that's all we prepare for today's webinar. Now we are welcome for any question you may have. Patrick?
Yeah, that's great. Thank you very much, Weiss and Roderick and your colleagues for a really interesting and very in-depth presentation. A lot of good data there. And like you say, it'd be good to get some other companies involved in sharing their experience. So as you say, we've got time for some questions and some discussion. So people are welcome to either put their hand up or make a comment on the chat line. Let me just ask a couple of things to start with. So when you're measuring the temperature of the containers inside and outside, the containers were normally empty containers, is that right?
Yes, that's right.
Does it make any difference whether there's cargo inside or outside? Does that make any difference?
I think so, yes. It will make difference. So we are consider the next step we may use the smart container for those loaded container to record the temperature change within that container. But however, there is still a limitation because it depends on how many sensors do you have within a smart container. Yeah. But that's certainly our next step.
And the temperatures were measured at the top of the container and the middle of the container, but not on the floor of the container. Does that make any difference?
We have checked with the thermal image camera to understand all the temperature distribution. So yes, we do have that kind of data. It is different. For example, why we hand the data logger 65 centimeters down below the ceiling is because we try to understand the temperature distribution within a container. That what we found is it is about 10 degrees difference from the ceiling to the 65 centimeters of right in the middle of a container. Yes.
Because the roof gets so much hotter, I suppose.
Yeah, that's right.
We have a question there, Christopher or Chris Elliott.
Yes, that's right. Hi, thank you very much for a very interesting presentation. I have worked quite a bit with these, particularly containers of cocoa beans, actually, and I know you were mentioning butter there, but I saw the beans were also mentioned in the presentation. For those specifically, really a recommendation more than anything, that it'd be very useful to get data not only of the temperature, but the using probably a digital hygrometer to get the humidity in those containers, because one of the constant issues that we see is when they're shipped in dry box containers with little ventilation is the issue of condensation at night as the sun goes down and the metal cools down below the dew point. So it would be very interesting to get data, as you have done with the temperature of the humidity in those boxes. Thank you.
Yeah, thank you very much. That's a very good comment. Actually, we do have those data because the data logger, it is not just record the temperature, also the humidity, also the dew point, the pressure, those climate elements. But still, we are working on it. I mean, well, analyzing those data takes time and manpower. But yes, thank you very much for your comment. We do collected those humidity data, the dew point as well at the same time.
One of the other points that you raised was the different colors of the paint. The containers have different colors. You have the green, your own green one, and then the maroon color of one of the leasing companies. So clearly that makes quite a bit of difference, the color of the container. Many of the container leasing companies who own half the world's containers, they like to have dark colored containers, usually brown or maroon. And I think we know the reasons why they prefer dark colors. Whereas shipping lines often prefer to have brighter colored things because it's a stronger message.
Yes.
And we have Philip Eastel on the call from Chiguku Marine Paints. He's just wondering if any trials have been conducted using thermo-reflective coatings on the exterior of the containers, especially the roofs. So it's a question whether the type of coating on the roof of the container might be looked at to reduce the temperature by some. Is that right, Philip? Reflective coating.
The reflecting coating?
Yeah. There's a
yes. Good morning, Patrick. Yes, thank you. That's that's referring to thermoreflective coating. So effectively, the sun's rays, the ultraviolet light, especially, and other infrared rays, are reflected away from the surface container, therefore avoiding or mitigating some heat leakage into the container. We've conducted trials on the decks of vessels, especially LNG carriers, and the results have been that the difference under deck is over a 5 degrees Celsius change in a deck that's coated in thermoreflective coating compared to a vessel where the deck isn't coated in a thermoreflective coating. So thermoreflective coatings may have an opportunity to help reduce the internal temperature of a container, but particularly the roofs are the area where you get the most reflection. And you're right, Patrick, yes, the colours do have a major impact as well on the absorption of heat or the reflection of heat.
Yeah, thank you very much for the good information. Did you just say 5 degrees difference between the thermoreflective coating and general coating? 5 degrees difference?
That's correct. The trials were conducted extensively, and there was roughly a 5 degrees Celsius difference under deck on the LNG tank carriers. So obviously for carrying LNG, there's a major commercial advantage in terms of the additional LNG you can carry.
Oh,
but
yeah.
The heat reflection was obviously the primary objective of developing the thermoreflective coating. We're also talking to some companies, shipping lines who operate reefer containers. I spent 5 years or so working with Daikin, and we worked on a number of let's say trials where you can see that the internal temperature of a reefer container as well can be better controlled with some thermoreflective coatings. Yeah.
Yeah, thank you. But sorry.
We can share more info with you if you like. I can send the results of that study to you, or to Patrick to send on to you.
That would be great. Thank you very much. Thank you. Thanks for the good information.
So one of the other points that you mentioned was the fact that the reefer containers didn't cool down, or at least the temperature didn't change so rapidly as the standard dry freight containers. Is that right? When they're on the terminal.
Yeah, because it has a very good insulation.
Insulation, right? Yeah, I guess so. Yeah.
That's right.
And clearly, putting them in the shade makes a big difference. But again, that comes back to the last part of your communication, the presentation about the planning. It's this planning, whether it's shipboard or terminal planning, and being able to plan that, which is not so simple, I'm sure, in a busy terminal. Planning where to put dangerous goods in a in a protected or shaded area, in a covered area.
Yeah, that's right. And as I say, in some of, if not all of them, those terminals in China, they have the 35 degrees threshold for activating the cooling system. However, because the information exchange is not so comprehensive at this stage, so they only cool those containers they know, the IMO cargo, but not those non-DG cargo, which is also critical to the fire risk. So I think this is also an area to be working on.
Yes, I mean, how much detail can one have? The detail of the cargo, when you're doing this kind of planning, it gets extremely complicated. And I could see from the last slides that your colleague gave, the system is there, but whether it can be implemented so easily.
Yes, that's right.
And then on board the ships, obviously the position, again, talking about the planning, but being near the fuel tanks makes a huge difference as well. In the cargo hold, where it's positioned on the hold makes a big difference.
Yes, that's what we have been doing, and we are just like to confirm the away from heat. Right. How effective is that for 12 meters? Then what's the change? But it is, in general, it is right. When the cargo is required away from heat, you never put that cargo near to the source of heat. We don't do that. We now have figures to prove that point.
Yeah, that's very good. Good. I'm just looking to see if there's any other questions, any other points. We've just got a few more minutes.
Maybe our participants need more time to digest this information. So I think, can we invite all the participants to send their question if they still have some question after this webinar? And Patrick, I think we will share this.
I'll share the presentation, and also we're making a recording. We'll edit the recording and we can share that, because I think it's clearly something that we need more data, and we need data from other shipping lines. And look, there's certain parts, the Pacific and then Asia to Europe as well, but maybe there's some other routes that people will look at as well. So that kind of data, but it requires quite a lot of planning to organize the temperature moderating, doesn't it? I know you spend a bit of time to set the whole thing up and to make sure you've got the right kind of temperature monitoring systems and so on. But there's a lot of data already, but we could do with some more information.
Yeah. And I think to all the participants, no hands right now, right?
Don't see any more hands. I think they're all they're overcome by all the information you've been giving them.
Okay, all right. Then, well, I want to thank all the participants for your joining today. Thank you so much. If you can provide us with your valuable comments and advice, telling us how to do this task better, that would be highly appreciated. Also, taking this opportunity, I want to thank Roderick, Yvonne, Justin, my teams. A good job. Thank you very much. Most importantly, Patrick, thank you so much for giving us this opportunity to brief you.
No, this is what it's all about, is sharing information. So again, thank you, Weiss, and thank you for the team for the work you put into this. As you say, I'll be sharing copies of the presentation and also a recording of it in the next few days. So very much appreciate it. Have a good day, everyone. Bye-bye for now.
Have a good day. Goodbye. Thank you.
Thank you, everyone. Bye-bye. Thank you. Bye-bye.